This is a continuation of the lesson on rational expressions, multiplying and dividing. The first two examples you saw just were your basic, almost Algebra 1 type examples, but now we're getting into what I think of as more the Algebra 2 examples. The skills you need basically are just factoring. This is where that factoring really comes into play. So on this first problem, first you want to check and make sure it's not division. It's not. So we can go ahead and move on to step 2, which says to factor everything. Because we have a trinomial there, or quadratic, you want to use the X box to factor. So we have a 40 up here, a negative 13 here, factors of 40 that would add up to equal negative 13, or negative 5, and negative 8. So put x squared here, 40 here, negative 5x, negative 8x, and you end up with x minus 8 and x minus 5. Alright, now that's just this numerator here, okay? That's the problem with these problems, is that they can be a lot of work, and if you mess up factoring, you can mess up the whole problem. Fortunately, we have a monomial here, so we can just leave it alone for right now. That's 80x squared. Over here, x plus 4 is a linear factor by itself, so it's fine. We have another quadratic, so we need to factor that. So that gives us a negative 32 up top, a negative 4. Let's see, x squared, negative 32. So factors of negative 32 that add up to equal negative 4, that's negative 8, and positive 4. Yep. Okay, so we have x minus 8 and x plus 4. Okay, so the reason we went factor crazy is that now all of this has been broken down into things that we're allowed to cancel out with each other. So remember, you can cancel things in the numerator with things in the denominator, but and it doesn't matter if they're like diagonal, they just can't be on the same floor. Alright, so we have x minus 8, so those cancel. The x plus 4's cancel, and so we're left with x minus 5 over 80x squared. Now we do need to worry about our excluded values. Now the excluded values, remember, are values that would make the denominator equal to 0. Where I look for that is right here, where I've already factored everything, but really before I've canceled things out. So right here, if I were to set that equal to 0 and solve, x could not equal 0. If I set x minus 8 equal to 0, then x can't equal 8. And if I set x plus 4 equal to 0, x can't equal negative 4. So right over here is our solution. Really, a solution is a word I don't like to use in this case. Technically, this is an equivalent expression. This is the simplified version of the problem you were given. So x minus 5 over 80x squared, where x cannot equal 0, 8, or negative 4. And that, altogether, is your final answer. Example 5 is just like example 4 in difficulty level. Just instead of multiplying, the first step is we need to remember, because it's division, woohoo, we get to flip. For some reason, I get really excited. I've always, even since I was a kid, loved the idea of flipping the second fraction. I just thought it was so cool. Okay. And so we have 6x plus 24 as our numerator, and that big mess is our denominator. Okay. Now that we have it set up as a multiplication problem, we continue on just like we did in the last one, and we factor everything, and then we're going to look for things we can cancel out. So the GCF right here is 5, so this is 5 times x plus 7. The GCF here is 6, and when you divide out that 6, you're left with x minus 1. The GCF in that numerator is 6, and 6 goes into 24 4 times. Oh, we have a little quadratic there. I guess I'll factor that way over here. So 1 times 28 is 28. B is 11. Let's see, we have x squared, 28. So numbers that multiply to equal 28 but add to equal 11 That's 7 and 4. So end up with x plus 4 and x plus 7. And the order doesn't matter, just so you guys know. Okay, so now we have everything factored and it's nice and pretty. And so now we look for things we can cancel out. The x plus 7, so we have an x plus 7 here and an x plus 7 there, so they cancel. We have an x plus 4 that can cancel with that x plus 4. That 6 can cancel with that 6. And what we're left with, the simplified version of this, is 5 over x minus 1. Yeah, and 5 over x minus 1 looks a lot better than all that. Okay, so almost done. We've done what I think of as the hard part. Now we just need to find our excluded values. So for our excluded values with division, we're looking at this stage, the factored stage, but we're looking here, 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 and here, okay? So looking for what would make my denominator equal to 0, because we can't have that. So you add 1 to both sides, and x can't equal 1. And it makes sense, guys. Y'all know that 1 minus 1 is 0, 0 times 6 is 0, so you'll be dividing by 0 there. And you can't do that. Dividing by 0 is undefined. So looking here, if you have x plus 7, that can't equal 0, so x could not have equaled negative 7. It also could not have equaled a negative 4. So let's get those set up. And from this one too, now that I already took care of there, but had this been a different number, I'd have one more to add on. So our final answer is 5 over x minus 1, but x could not have equaled 1, negative 7, and negative 4. And that is everything you need to know for Monday's lesson. This is pretty much everything with multiplying and dividing rational expressions, and I hope you understand this.